Okay, so the original tangent definition for kind of like this stuff that we were using is that tangent is, of an angle is equal to y over x. And then also remember cotangent is x over y. I can write theta. I like thetas more than alphas. No, you like the alpha, you like the fishy ones more? Okay. So those are the basic definitions that we're going to be using. So to use your unit circle then, and with your unit circle, we'll just look at some of the points and kind of make some of those. So we will be putting it on a piece of graph paper. So if I wanted the tangent, I need to know the y and the x. So like I'll kind of just go through and write down like the nicer points, I guess. So we'll just be using each thing. So the nice points that I kind of have on the graph paper, I have zeros. So at 0, angle 0. So if I say that my theta is this, what's my x and my y for each thing? And then we will need to know our x over y, and that will give us the points to plot on the actual graph, okay? So we have to look at the unit circle, so this is kind of the process, and then everything will be basically shaped like these two today, tangent and cotangent are shaped really similarly. So it won't be too hard to look at after that, after we kind of have this basic one done first. Okay, so I will do like the pi over 4s. So if I say pi over 4 is my angle, so 45 degrees, both of them are square root of 2 over 2, square root of 2 over 2. Maybe if I can write a do. So then if I wanted to do x over y, that's just 1. Square root of 2 over 2 divided by square root of 2 over 2 is just 1. Okay, so I could go through like all the gross looking stuff on that. Let's see, how much more stuff do I need? How about also at 0, I should have wrote down like my 0 angle first. I don't know why I didn't. So if I had 1 and 0, the x over my y is undefined, right? I can't divide by 0. And what that is going to look like is everywhere I have an undefined, I am going to have that vertical asymptote thing going on. Okay, so is this the first one that I'm doing? Except for right now, I'm basically doing cotangent, okay? Not tangent. Okay, x over y, just make sure that I'm noticing that I'm doing cotangent, not tangent, because I wrote x over y, not y over x. Okay, so then my next angle that I'd like to know would be 90, because that works out nice. But, yep, so 90 is pi over 2. So my x and my y is 0 and 1. So normally I would have wrote this in order, sorry. So if I did x divided by y, 0 divided by 1 is just 0. Okay, so let's kind of just go around the whole circle and do like those 45s to get like nice places. And so I wouldn't even necessarily be, like you're not going through this process every single time. Like you're not writing out the whole chart. You could probably just stick it right on the graph on the point to make a point on that graph paper, okay? So then at 3 pi over 4, 135 degrees, 3 pi over 4, negative square root of 2 over 2 divided by the square root of 2 over 2 is going to give me negative 1.
Your stick graph.
Is hanging up on my calculator thingy.
Okay, so do we need to have this graph?
Yes. Okay, so let me get one more. So then if I did negative, so at pi, my angle pi, 180 degrees.
Jesus Christ, Boger.
Okay, so then if I have negative 1 and 0, that's also another undefined. I don't know why I'm spelling it all the way out. Okay, so now I'm going to try to go through that and put them all on a graph. Okay, so I have 2 undefined, so I have 2 asymptotes between 0 and pi, so that was just not, it's not even like all the way around the circle yet. Okay, so at 0 for cotangent, then at pi, I have those vertical asymptotes. Then I can get all these other points trying to get plotted on there as well. So with that then, at pi over 4, I'm up 1. And remember, I'm counting by halves on my graph paper. Okay, next thing I have, pi over 2 is at 0. And at 3 pi over 4, I have -1. Okay, so what actually is happening, so it kind of looks like we could actually make a straight line, but we can't cross those vertical asymptotes. So what actually happens is it comes up here, and it has a swoopy deal, and then it goes back down with just never crossing that vertical asymptote. Okay, and this dude is going to repeat forever. Okay, so if I kept going around this circle though to do, let's see, -5 pi over 4. Down here I have a negative square root of 2 and a negative square root of 2. Negative square root of 2 over 2. Negative square root of 2 over 2. I still get back to a +1. So I have that pattern repeating, and it would have looked more like it was repeating if I had wrote 0 to begin with instead of right there. So then my next dude, I have 3 pi over 2. Is a nice one to look at. I have 0 and -1. So I'm back to 0. And then at 7 pi over 4, I have a square root of 2 over 2 and a negative square root of 2 over 2. Divide those together, get -1. Okay, so I have a 1, 0, -1 again. So these guys are kind of flip-flopped. So they're gross looking. Okay, so I have this pattern repeating. So even if I go all the way to 7 pi over 4, so if I get back to 2 pi, I have the same thing that I had at 0. So that's just this same thing again. So I'm back to, I have another vertical asymptote at 2 pi. Guess I'm trying to. Okay, so then I have a 1 at 5 pi over 4. So finding that spot, a 0 at 3 pi over 2. Another -1 at 7 pi over 4, so I have that another swoopy deal. Okay, so that swoopy deal is like the basic cotangent graph. So your basic cotangent graph is like this. So when I had one period of a cotangent graph, it's actually just pi. Okay, so it's considered your basic, like, so for sine, cosine, secant, tangent, when you were trying to figure out your period, you were doing 2 pi divided by that number out front. Okay, so it's going to be pi divided by whatever number I have out front. So let me finish writing this and we'll do like a quick tangent graph real fast. Okay, so tangent is y over x, so I'm just adding to this dude. So tangent is y over x here is +1. 1, 0 over 1 is 0. 1 over 0 is undefined. Okay, so basically just the zeros flip-flop. -1, negative, still get -1. The undefineds are switching places with the zeros, so undefined is now 0 for a tangent instead of cotangent. Okay, so hopefully like you have the idea of the graphing, that you don't have to go through this entire process to do this whole entire thing, but you're kind of just getting the idea of it, and then you will be able to do it. Okay, negative and a negative make a +1. Y over -1 over 0 is undefined. Negative square root of 2 over 2 or positive square root of 2 is -1. And then 2 pi, I am back to what I had for 0. Okay, so I still have a couple undefineds. So when I go to graph tangent on this dude, so I'll try to do this on this guy, tangent of the angle, I have my vertical asymptotes at pi over 2 and at 3 pi over 2. And yeah, so pi over 2, so I get this line at pi over 2, 3 pi over 2. Okay, and plotting these points, so at pi over 4, I have a 1. So at pi over 4, I have an up 1. At pi over 2, that was my undefined, so at 0, I had a 0. Okay, but on 0 on my cotangent, I actually had that vertical asymptote. So these are kind of the zeros and the vertical asymptotes are switching places from tangent to cotangent. Okay, so then what's my next dude? So 3 pi over 4, negative 1. So 3 pi over 4, negative 1. 3, what's my next thing? At pi, I'm at 0. Pi, I'm at 0. 5 pi over 4, you're at 1. Okay, so you can kind of see this is my first swoopy deal that I actually had the whole swoopy thing. Okay, so tangent, cotangent, pretty much exactly the same except for tangent has like a positive slope. A positive, it's not necessarily, you can think about it as slope. I'm going to say it has a positive swoopy thing. Cotangent has a negative swoopy thing.
How would you just find out that?
One period of this, you don't have to go from like 0 to 2 pi. You just have to go from like 0 to pi, or it could be negative, what was this, dude? Negative pi over 2 to 2. So it could be like that. Okay, so whichever one works better. You would not have to draw 2 of those, though. So remember, like a secant and cosecant, you had to have one up and one down. This whole thing counts as one period. Okay, so just one swoopy thing is one period on these guys. All right, whatever.
Is there more? How?
Well, not tons more.
Some?
So your basic form is A tan B x plus C. That's a C. That's not a C. I was just going to give you like the basic graphing things, but you guys do pretty good without like the instructions.
Jutro added a photo.
I see that. LuLaRoe. Gotta love me some LuLaRoe.
What the hell's that?
Oh, it's clothes, and they're great. Okay, so your first step is to find the period. And your period is going to be equal to pi divided by the b, so that number that's in front of the x. Vertical, your phase shift is going to be your c.
You won't handle some of these.
So same type of organization that the last one had. Vertical is D. Okay, so your asymptotes for tangents. Asymptotes. So this is all just for the tangent graph. I remembered to actually write them separately. Is at x is equal to c plus pi over 2b. Okay, so I need to start with my phase shift and then add to that whatever like that period piece is going to be half of the period. Okay, so I have the horizontal asymptotes at half of that piece. Okay, so the midway point for inflection. So that was kind of this center point. So for tangent, the center point is called the point of inflection. Okay, that happens at CD. Is point of inflection. And you'll need to then sketch the other points, so then you'll have to find kind of those other 2 points that are going to happen. So if this is midway between the asymptotes, then you have to, okay, this is midway, up however much. That up however much it is going to be that, that dude. Okay. That's weird. Amplitude, but I don't know that it's necessarily called amplitude for tangent and cotangent. Okay, so you'll have to find these other 2 points, and that how high that is off of that A. Okay. So cotangent rules. Let's write those down real fast. Plus, minus C. Thank you. Stop.
Now, learn, read.
Okay.
Learn, read.
Hey, I didn't get a C3. I was cutting my nail.
No, it's not. Did I have that as a plus? Yeah. No, change that to minus. Okay, so just because minus is, if it's a minus, it's going to move to the right for your phase shift. If it's a plus, it's still moving to the left. So same kind of rules we were using. I just didn't mean to write that down wrong. Okay, so then your cotangent stuff. Let me get back to the list of cotangent that they have nicely. Okay, determine the period. Period again is pi over whatever that b happens to be. Phase shift is c. Vertical translation, I'm not gonna write those down. You guys are comfortable with those, I think. Okay, to your next type of thing, your asymptotes. Asymptotes are going to happen at x equals c, so whatever that vertical translation is. And then your other one is going to happen at x is equal to c plus your period. Okay, just remember to recognize that dude as your period. Okay, your midway point, your point of inflection.
Mine not spelled that one good.
Okay.
With yourself.
Oh my god.
Stop. I am recording right now. This is so your midway point is going to happen at c plus half of your period.
You guys are stupid.
That's a b.
That's so funny.
Did I have to say period all the time?
No.
No, them being gross. Okay. Them
makes
being
me
gross.
so sad.
Gross.
No. No.
And then remember that you still have to find those other 2 points in there. Okay, so again, that's your midway, dude. So you have your vertical asymptotes wherever that phase shift starts, and then plus your period. Okay, and then remember like
Put my sock in
cotangent.
your mouth.
Ew. Okay, remember that cotangent normally has this shape. So if I talked about a negative cotangent, it would then have that shape. Okay, tangent, a positive tangent. Remember that a positive tangent is normally positive. So if I asked you about a negative tangent, okay, and that negative would be like where that A would be for either one, it would look like that. Okay, so just be comfortable with when those are going to switch sides a little bit. And then questions for you guys. So that's back to the thing I had it on. Okay, so I think you can find the calculator ones pretty easy for tangent, and then cotangent. Make sure to type in cotangent in the calculator. You would do 1 over tangent of whatever they would have had you typed in, okay? Make sure you're in radian or degree mode, whatever mode it is you need to be in. It looks like most of them are going to be degrees, or not degrees, they're going to be radians, sorry. And then problems. So 1 through 6, and then 7 through 67 odds.
If I have to graph more than 10 times, I'm gonna slip my phone.
How could the redneck mom tell that
Well,
her daughter
if we
was
do,
on